So we're continuing with logarithms here, and what we're going to find next is a little bit interesting and kind of fun. Um, Logarithms have some properties that allow us to expand them and sometimes to go in reverse and contract them. That can be very helpful mathematically. So let me show you some of the tricks here. Now, the OpenStax book starts off with some confusing, instead of very basic ones, they go to some real complicated ones. So I'm going to jump through some of these. But the root ideas are pretty simple. So again, they've started with a difficult one. But so suppose I had something like this. Log base 5 of 7x. Well, the point is, and I have an activity to kind of try to show this, but if two things are being multiplied inside of a log, it turns out that they're the same if you turn it into two separate logs that are being added. So 7x can be turned into log 5 of 7 plus the log base 5 of x. So if we're looking down here, remember all of this, because it's in parentheses, the 3x plus 4 is all one number. So really what I have here is three things being multiplied, 30 times x times that entire number. Okay, so then they can all be expanded. Well, oh wow, they've really gone far with this. I wouldn't have asked you to do this. They've broken 30 down all the way to its parts. Let me just show you what I would have done. I would have been looking for this. So I've got three things being multiplied inside, and they could all be split up thanks to this property for the product rule. If they're being multiplied, they can be broken down into addition. Okay, so I'm sure you see where this is going here. We could turn this into this, where they're being multiplied, and so I can separate them into addition. All right, now again, I'm going to come back. This has got quite a bit going on here. I'm going to just show you a basic example and skip this for now. I might come back to this one. There's some good ones later too, so I don't know if I'm coming back. But if you are dividing inside that logarithm, you can also turn that into subtraction. Does that make sense? So I can turn this and I would get the same result if I divided those two numbers or if I subtracted them as separate logarithms. So again, they went real hardcore, and the problem is the order of operations on what they're doing here is much more difficult. So I'm going to skip these and talk about the problems that can come up later. So we've got one final rule. It's the power rule. So if you have an exponent inside of a log, it turns out you can just put that exponent out front. And so here I could turn this by just taking that exponent of a 5 and setting it down in the front. So if we were trying to do this, so they'll call it expanding the logarithm, I can put that power out into the front. Okay, I was looking at this like, well, what could we do with this? Well, here's what they're getting at. So you look at this, well, this isn't any of the rules we talked about. Well, we could think of this actually a couple different ways. Isn't 25 5 to the second? So what I could do is then I could rewrite 25 as 5 to the second, which would allow me to bring the exponent out front. Okay, now here's another one they're trying to be a little tricky with. I'm going to think of this as x to the negative second. Isn't that the same thing? Doesn't it, the exponent switches signs if I move them across the fraction bar, which allows me then to make it negative 2 ln of x. All right, they're asking us to just go backwards. I've got a 4 out front, but I can make that an exponent. So right here I've just put the 4 back, so I've condensed it or back into an exponent. Okay, same thing here. I could just put the 2 back, and now it would be log 3 of 4 to the second, or log 3 of 16. So I've condensed it back together instead of expanding it. Okay. Yeah, let's talk about the order of these here. So I have to think of them. If you have a bunch of them in order. Here's the steps you're supposed to follow. But the order of operations with this gets really complicated, and quotients in particular. I've seen it in OpenStax and in some other books where the order doesn't make intuitive sense, and sometimes they get very complicated and something will go wrong. So I'm going to show you on this one, but then I'm going to tell you a trick that it's going to fix this so that you're not going to have any issues. It will work every time. So the first thing here, I'm going to do my quotient, which is I'm going to turn this. I have division going on, so I'm going to turn this into subtraction by dividing. So that's being divided, I turned it into subtraction. Now we move to the product rule, which is these are all being multiplied, so I'm going to split them up. And then finally we're going to bring the exponent rule says I can bring the 4 down. And I turn it into this. Okay, let me see if we can get to a more complicated one and I'll show you. Okay, so here's the trick. What I'm going to do to avoid the quotient rule, because it can run into some problems with order of operations, I'm going to just always bring anything from the bottom up to the top. I'm going to make everything an exponent and I'm going to bring it all up to the top. So here's what I mean. Wouldn't you agree this is the same thing? I have just removed z to the 4th from the bottom, I've moved it up top, and now it's z to the negative 4th. Now why have I done that? Because now I'm just going to do the product rule and then the exponent rule, and it's all going to work out without any difficulties that can arise. The quotient rule can introduce some difficult issues, and this will avoid them. And so now I'm going to do these, well, I better not. I'm trying to be fast, but I should do it in 2 steps. Okay, so now I've moved him up to the top. Now I just use the product rule. I can just add all of these as individual logs. And then lastly, we would do the exponents. Now watch my trick. By making this a negative 4 exponent, I can then move that in front, and it becomes negative 4 log of z. So again, by moving this to the top and starting with everything on top, it's going to eliminate any of the order of operation issues that can come on more complicated problems. Okay, so here again, I'm going to make everything an exponent. So instead of x, square root of x, I'm going to make this x to the 1/2. Aren't they the same thing? Do you remember back that a square root is a 1/2 exponent? So I could then make that 1/2 log of x. Okay, now I'd recommend you pause and try it. But do you see what this would be? Do you remember how to turn this into an exponent? That would be x to the 2/3. The root, the index there of 3 on the root becomes the denominator of the fractional exponent. So I can then expand this as 2/3 ln of x. All right, now here's where things get crazy, and this is why my trick will be even more important. I'm going to just move everything up to the top. So I'm going to turn this into 64 x to the 3rd, 4x plus 1, 2x minus 1 to the negative 1. Do you see what I've done? I've just given this an exponent of a negative 1 by moving it up top. Okay, now all I need is the products and the exponents. Now this is really like 2 things being multiplied. So how about this? I'm just going to show you where it would go and see if you're following me. Okay, so I've done the product rule and exponent at the same time. So 64 and x to the 3rd are being multiplied, so I can split them up. And then the exponent on the x came in front. That was the exponent rule. Everything else is being multiplied, but notice this negative 1, when I brought this up to the top, that negative 1, when it comes in front, makes this negative log of 2x minus 1. So I hope you followed that. I wasn't going too quickly. But the key is I avoid the quotient rule by bringing this up and making it 2x minus 1 to the negative 1st power, which means it moved to the top. Okay, now you could try this one if you want to. This one's pretty complicated. I'm going to turn everything into an exponent and move everything to the top. So look what I would have. Everything on the top is inside of a square root. So I'm going to make this, everything up there is going to get a 1/2 power. So he gets a 1/2. And now he gets a 1/2, but he was already to the second. So he's going to be 2 over 2. And then finally, I'm going to move everything on the bottom. I'm going to move it up to the top by giving it, in this case, a negative exponent. Now, all I have left is the product and the exponent rule, and you won't have any troubles with this. So I'm just going to do it all at once. Now this is 2 over 2, so that's like 1 moving down in front, so I don't really need that. And then finally now I move this up top, so it's a -1. So I'm going to make it negative ln of x squared minus 9. All right, now the entire next video is on putting them back, condensing them. But here's a basic couple, I think, as we end. So if we were wanting to put it back, I can multiply the 5 and 8, like we're going in reverse. So the addition means multiplication. So I can multiply the 5 and 8, and then I divide by the 2. So do you see, putting them back together, these would become that. And then the subtraction becomes division. Tidy this up, and I get down to this. Now the reason we would contract them, we would want to simplify. So I would want to multiply the numbers back together and do the division so that we get down to here. So we would be doing these tricks because there was some value in either expanding it or some simplification that could come by condensing it. Okay. Yeah, now this is, I'm actually going to make these exponents because it can get tricky. This is one of the order of operations issues that I want to point out here. So I think this can go wrong unless you do this. I've made those negatives into exponents. I brought them up as -1 exponents. And what that tells me is now I have this whole string of stuff, but the 4 and the 6 are going to go to the bottom. Like if you don't do that, it becomes very confusing about when you're supposed to divide something. And if you do the exponent trick, you won't mess up. So I saw repeated subtraction in one of these, repeated division, and that's where the problem happens. So what I've done is I've made them both -1 exponents, which tells me this. I've got this whole string of stuff being multiplied. If I put it back together now, 3 and 5 are on the top, 4 and 6 are on the bottom. You following that? So this will eliminate any confusion about how you're supposed to divide and where that's supposed to happen. This is much, much safer. So I'm left with that. Okay, I thought we were done there. We got some more here. Let's put this back together. Let's see. Yeah, so it's kind of easier to do it all in one shot, but yeah, that's not going to help us. All right, so if I put the exponents back, well, I don't know what to do with this. I don't know if I should just, I'm going to just do it in one shot because I don't think it helps all that much to not. Yeah, there's going to be more tidying up that needs to be done here. Okay, now see if you can follow my first step here. Here's what I'm saying. I have these two guys are going to be multiplied because they're addition. And this 1/2 is going to go back up as an exponent. Now that's going to be a square root, and I'm going to deal with that in just a minute. But for now, we're just going to do one step here. Now here I have the -3. So if I make that an exponent, then all of this is going to need to go on the bottom to the 3rd power. Can you follow what I've done so far? So I moved the exponents back, and I've multiplied. And he went back on the bottom because of the -3. Now let's tidy this up a little bit. There's some work we could do here. So this is x squared. A 1/2 exponent is a square root So he would be a square root of x minus 1. And now down here on the bottom we have a power to a power, which you multiply. And you'd get x plus 2 to the 6th. Yeah, I don't think doing it slower would be all that helpful. I hope you processed what I was doing there. Let's try another one. Yeah, the quotient rule again I think would get you into trouble on this. So I'm going to treat this as, I'm going to do my trick with the exponents. So see if you can follow what's happening here. Okay, see if you can follow this. So 5 is going to be on the top. This is a half exponent. It's going to be on the top because it was positive. This is like a negative 1 exponent, which is going to put it on the bottom. And then this is a power of 3 as an exponent, and it was positive, so it would be on the top. Now, nothing else really combines here, but if you had a 1/2, I would want you to turn that into a square root. If I were going to give you full credit, this is what I would be asking for here. So a 1/2 exponent is a square root. Oh, I'm sorry, off all of this, I've lost the fact we need to put a log there. Yeah, so I need a log in front of all of that. That's what we're doing here. It condenses down into one log, and that's what we would get. Okay, complicated, but I think it's a little bit fun, and I think with the exponent trick, avoiding the quotient and using the exponent trick, I think you'll get the hang of it.